Okay, absolute value functions, you've used these in the past. What I've got is the piecewise function version of absolute value, just because we've got done talking about piecewise functions. But basically, if you were to ever see these vertical lines, it means that whenever you have in here, so like -3, absolute value of that becomes positive. Okay, even if you were to work this out, say like you got 3 minus 5, treat the absolute value like a set of parentheses. Do all your order of operations inside of it first, and then take the absolute value, and that becomes 2. Now, don't get too tricked out on absolute value. Sometimes you can take the absolute value of a number, like say -7, and your answer can still be negative if there's a negative on the outside of it. Okay, so like this would say take the absolute value of -7 and get 7, and then keep the negative to it. So -7 would be your evaluation there. But anyways, I'm going to start introducing this concept. It's called parent functions. So the very basic bare bone absolute value of f of x equals absolute value of y of x, or y equals. So I'm going to pick some x values, -2, -1, 0, 1, and 2. If you want, you can put in -3, -4, -5, and I can keep on going 3, 4, and 5, and so forth. And I'm just going to evaluate those values. Get 2, 1, 0, 1, 2, 3, 4, 5. Plot them from the origin, so I'll go over -2 up to, and keep on plotting those points, and I keep on going beyond, and I got something that looks like a v. So when I say parent function, everything I'm talking about and the other absolute value function I'm talking about is comparing it to this, where this guy has a vertex, might have heard that word before, at 0, 0, when we're talking about parabolas. In this case, it's the lowest point. Now, domain we'll start talking about, and that's all your x values that go in. And there isn't any x value that I can't plug in and take the absolute value of. So x is all real numbers. And for now, that's usually going to be all of our domains. But if you notice, your graph doesn't dip below the, and I'm sorry, I should say this, your range is your y values, what gets spit out. None of my y values in here are ever negative. So my range is y is bigger than or equal to 0. Okay, and if you look at your graph, none of these purple dots that I graphed go below 0 on the y-axis, or on the, y-axis. So we can take that parent function and move it. Okay, here's the standard form or the general form of an absolute value function. A is the value on the outside of the absolute value. It's going to tell us a lot. It's going to tell you, and I'm going to skip to this vertex for a second. But A, if it's bigger than 0, it opens up, so I get a V that goes like this. If A is less than 0, so a negative number, it opens down. It's reflection if you remember geometry. If that value is between 0 and 1, for example, if it is like 1/2, 1/3, something like that, it's going to be wider than our absolute value of x, our parent function. If A is bigger than 1, so example, if A is 2, 3, 4, or even 1.1, it's going to be narrower than our parent function. And I'll teach you this little slope thing here in a little bit. Now, back to the vertex. Inside of the absolute value is going to be this h value. Careful, minus is part of the formula, kind of like you have different signs to different formulas. And the plus is part of the formula as well. So that h and k are going to be your vertex. So we're going to take that 0, 0, and we're going to move it left and right with that h value, and that k value that we're going to move it up and down with that k value. I just said that again. So here's what I do. I looked at the a value, and I compare it to y equals a absolute value, of x minus h plus k. And I just look down at each of those numbers and identify them. So a is a -1. Well, what does that tell me? Oh, it's negative, so it's going to open down. Okay. My vertex, and I'll talk about the moves and kind of vertex being the same thing, but h is going to be at 1. Careful, the minuses are part of the formula, and then k is going to be at 1 as well. So my vertex is now at the point 1, 1 instead of 0, 0. Well, didn't that take my graph and move it to the right one block and down 1 block. Is it narrower, wider, or the same compared to the parent function? Well, it's the same because 1 doesn't make it narrower or wider. And now I'm going to use a equals 1 as a slope. So I'll go down 1 to the right one, down 1 to the right one, down 1 to the right one. And that's going to be half of my v. Okay, and to get my other one, I'm going to use the opposite sign slope. If you remember about parabolas, just like absolute value, these things are symmetrical. Yeah, so it's like the same on one side of a line as it is on the other side of the line. Okay, good. So now my domain, like I said, all these are going to be x is, and you'll see me write this double-lined r, all real numbers. Every single number works for the function. But now it flipped upside down. So now y is less than, so I do have some negative numbers, and equal to, now the highest point on my vertex is 1, so y is less than or equal to 1. Yep. Go through it again, right? I'm going to compare it to a x minus h plus k. Okay. A is 4, so it's going to open up, and it's going to open up narrower. H is 2, and now we got k that's a minus 3. So now the vertex is at 2, negative 3. So the graph just moved from 0, 0 over 2 down to 3. There's my vertex. So it moved to the right 2, the graph did, and it moved down 3. And I'll use my a value as a slope, so 4 over 1. I'll go up from my vertex. Okay, it's very important, graph from your vertex, up 1, 2, 3, 4 over 1, up over 1. And I might have miscounted there on my little graph paper. And then I'll go to the other direction to get the rest of my points to make it a narrower looking V. Okay, my domain is x is all real numbers. It's opening up, so now it's back to y is greater than or equal to. And maybe you've caught on, maybe you haven't, that's okay. But I already know my range based off of that k value. Negative 3 is my lowest value. Okay, a little bit wider. Yeah, again, look at my a, here's my h, here's my k. It's going to open up, but now wider because 1/3 smaller than 1. Careful, this should be minus, so x minus h, so I got to make that a minus and negative 3. So it's kind of counterintuitive, the opposite of what you think, but now your vertex is over at negative 3, negative 1. So over 3, down 1, my graph moves to the left 3 and down 1. Okay, use that slope of 1/3, so I'm going to go over 1 and then, let's see, up 1 and over 3, up 1 and over 3. Up 1 to left 3, up 1 to left 3. My points might be a little off because of my little tiny graph paper, but you got to get the idea. Domain x is all real numbers again. Since it's opening up, y is greater than or equal to. And again, I look at that k value, negative 1. And now I've got another example here, but hopefully this is enough to kind of get you started.